All right, multiplying fractions, section 2.4, part B, part 2, our final part. We've separated decimals. We did decimals in part A. We did those yesterday. Fractions are today. We're still going to multiply and divide, but we're going to work with specifically just the fractions today. And the first step when it comes to multiplying fractions is to convert any mixed numbers or whole numbers that you have into improper fractions. I know that when we added and subtracted, I told you this was optional, that you could leave them as mixed numbers, but there's a reason your sixth grade teachers had you convert everything to improper fractions. They knew that you're going to have to do it anyways when you multiply and divide it. Okay, so if you've been doing that, that's fine. If you've been trying to leave everything as mixed number, that's okay for adding and subtracting, but I can't do that here when I multiply. I have to use improper fractions. The second step is a forgotten step that I think you're really going to want to use this year, and it's canceling. Okay, the second step is to cancel. Oops, if I could write it. Canceling is reducing before you multiply. Now, what happens to two numbers when you multiply them? What happens when you multiply numbers together? They get larger. Yeah. Is it easy to reduce numbers that are small or numbers that are large? Small. Canceling is going to save us a ton of time. And I'll show you more here that when we do some examples. When you multiply fractions, you multiply across the top and the bottom, and we're going to count the negatives. In fact, we could even do that first if we wanted to. Just don't forget to do it. Make sure you have the positive or negative answer. This is really important. Do not find a common denominator. Don't do it. I'm going to see people do this on their quiz Friday. It's going to drive me crazy. There's a reason that multiplying fractions is easy. You don't need a common denominator. This isn't adding or subtracting. Let me ask you this. Did we have to line up the decimal points when we multiplied decimals? Getting very few responses on this. No, we did not. So I don't need to line up the denominators either. Okay, I don't need to get those common denominators to be the same. Not when I'm multiplying. When I'm adding and subtracting, sure. That's why we don't like adding and subtracting fractions as much. What do I mean by canceling though? Well, canceling is like reducing, but you can do any top number and any bottom number. So when I look at this problem, before I multiply, can you tell me, is there anything that goes, any number or any two number, any top and bottom number that have common factors? Common factors. Ella, what do you see? 22 and 4. What goes into 22 that also goes into 4? 2. 2 goes into 22 11 times, and 2 goes into 4 twice. So even though they're diagonal from each other, we're able to reduce them in the same way that you would reduce this fraction right here, 4 over 22. If I gave you this fraction, you'd say, well, that reduces to 2 over 11. And that's exactly what canceling does. Canceling is the same as reducing, but instead of just top and bottom, right over top each other, I can also do it diagonally. I can do any top number with any bottom number. Speaking of which, that means I'm not done canceling then. What do you see that goes into a 9 that also goes into 15, Anna? 3. 3 goes into 9 3 times. And how many times does 3 go into 15? 5 times. Before I started this problem, you may have known what 4 times 15 was. Maybe you didn't. But did you know what 9 times 22 was? No, you'd have to go off to the side to do that, wouldn't you? What about now? What's 2 times 5? What's 3 times 11? And you know what? We don't have to reduce that. Why don't we have to reduce it? Because we canceled. If you cancel as much as you can, you'll never have to reduce. And if you challenge me on that and say, wait a second, I canceled, you marked this wrong, I'm going to say you probably should have canceled more than, right? There was more that you could have canceled. It's easier to do it. Guys, this is, I believe this is, 60 over 198. Do you want to cancel that? I wouldn't want, or sorry, do you want to reduce that? I wouldn't want to reduce that. It's easier to cancel when the numbers are small. It's easier to cancel a 9 and 15 by 3 than it is to try to cancel 60 and 198. I didn't even know 3 went into 198, but it does. I don't care actually, because I'm not going to get that. Don't try to reduce at the end. You are making it way more complicated, or way more complicated for yourself than it needs to be. Example B. I see a integer here, which I can turn that into a fraction by doing what? Put it over 1. Boom, now it's a fraction. Do you see any top number that can cancel with a bottom number? Oh, thanks, Parker, for volunteering. Do you see any top number that cancels with a bottom number? Parker? Parker, there is one. Look at the top right and bottom left. What numbers are those? What goes into 9 that also goes into 18? 3. Or 9, yeah. Now, there's no harm in taking a 3 out. Here's what would happen if you took a 3 out. And then you might notice you could take a 3 out of 3 and 3 out of 6, right? You could keep going. So just like if I reduce fractions, if I reduce by a number that's not big enough, I can just reduce again. You could still do that. Or if you're like Parker and you catch yourself, you're like, whoa, wait a second. 9 goes into 9 once and 9 goes into 18 twice. That saves you just a little tiny bit of time there. That's as far down as we can get it canceled. So someone tell me what 5 times 1 is and 2 times 1. How many negatives do we have? 2. Do they pair up? Yes, they do. They make a positive. Do I need to write this as 2.5? No, I do not. You can leave it as an improper fraction as long as it's reduced and our fraction is reduced. Okay. Example C. Still not sold on the canceling, you say? All right, we'll go ahead and do 27 times 11 and 55 times 36. I'll catch up with you tomorrow. The rest of us, what number goes into, well, I won't even say. Just tell me, what do you see that cancels, Hannah? Okay, awesome. 11 cancels by 11 to make a 1, and 11 cancel. How many times does 11 go into 55? 5 times. Okay. Anything else before I multiply? What do you see, Georgia? That's right. 3 goes into 27 and it goes into 36 before I do 3. Is there anything bigger than 3 that goes into 27 that goes into 36? Branson, what is it? 9. Yeah. Georgia, that works, by the way, and you just do it again. That's fine. 9 goes into 27 how many times? Anybody? 3. 9 goes into 36 4 times. And again, if you just would have done 3, then you would have gotten 9 and 12, and 9 and 12 would have given you the 3/4, right? So that it's again, if you cancel by 3, you just have to do it again. Let's multiply now. Oh, you're still working on the 55 times 36, are you? Okay, what's 5 times 4? 20. Yeah, that was easy. What about the top number? What's 3 times 1? How many negatives do I have? Nobody to pair up with. There you go. Example D has 2 mixed numbers. Bryce, what's 3 times 3? Plus 1. Okay. 10 over 3. Ashlyn, do the same thing. What's 10 times 2? Plus 7. Notice I didn't write the negatives. I don't need to write the negatives. I'm smarter than that. I can tell you that 1 negative makes your answer negative. Put it down there where you're going to write your answer. That way you're not getting confused in the problem. Anything cancel here? Georgia? Oh, yeah. 10 goes into 10 once. 10 goes into 10 once. That's going to make this a lot easier. What else, Maddie Yentes? What else cancels? Yeah, 3 goes into 27 how many times? 9. Okay, and 3 goes into itself once. And that's going to give us negative, what's 1 times 9? 9 over 1 times 1? Okay, I lied to you. There's one time that when you cancel as far down as you can, that you would still have to reduce. And that's if you end up with a problem like this. canceling is still going to give you a 1 on bottom in this case, but I can't write this as -9/1 because -9/1 is the same as just -9. That's the only time that canceling won't give you the final answer reduced, because canceling still is going to have, if you get these bottom numbers to be 1, it's still going to be 1 times 1 is 1. And we know that if, like for example, that last one, if we just said -9 is the same as -9/1, then I need to convert that, if I get -9/1, back into -9. So anytime I get a number over 1, just write the top number. Big ideas will count it wrong because they'll say it's not reduced all the way. And they're right, it's not reduced all the way. Just write it as -9. All right, dividing fractions. Still need to convert my mixed numbers and whole numbers into improper fractions. And then 3 words that you're awfully familiar with from last year are what, Maddie? That's right. Keep, change, and flip. Now, we've done a lot of keep, change, opposite this year, turning subtraction problems into addition problems. This isn't keep, change, opposite. I'm not going to take the opposite of that second number and make it positive or negative. I'm going to flip it upside down. In math, when you take a fraction and flip it upside down, that's called finding the blank. What do you call that fraction when you flip it upside down, Ella? That's right. Nice job. Reciprocal. Yeah. There's a Jeopardy $500 question for one day when you guys get on there, and whoever the Jeopardy host is asking you that, you can say, oh, it's reciprocal. I remember that from middle school math. You can still cancel, but notice where canceling comes in. Canceling happens after you change it to multiplication. You can only cancel on multiplication problems. You can't do it on division problems. So you got to change it. Keep, change, flip. Now you can cancel. First example, keep, change, flip. Again, notice I didn't put the negative there. What's one negative make your answer? Negative. Okay, there it is. It's in the answer now. Anything cancel? What? 4 and 8. What goes into 4 that goes into 8? 2. Anything else cancel? What? Maddie says? The 2 and the 4. What goes into 2 that goes into 4? Okay, so 2 goes into 2 twice and 2 goes into 2 once. And if I reduced by 2 twice, doesn't that mean I could have just reduced by 4 once? That would have given me the same thing. That's okay if you didn't notice that. So I'm doing on top 1 times 2. What's that? 2. And on bottom, I'm doing 1 times 3, which is 3. -2/3. Canceling is okay once you change it into multiplication problem. Example B. How do I turn -2 into a fraction? Put a 1 under it. There. All right, that's done. What's 2 negatives make? Positive. All right, that's done. Keep, change to multiplication. What do you get when you flip 2 over 1 upside down, Maddie? 1/2. What cancels? Nothing cancels. Sometimes that happens. Have you ever gotten a fraction that never reduced before? Yeah, it happens a lot, doesn't it? If you get a problem where you can't cancel, that means that nothing here is going to reduce. So we're ready to multiply. What's 3 times 1? And 4 times 2? 3/8 doesn't reduce, and it's positive. There you go. So even if it doesn't cancel, you're not wasting your time by checking, because you're going to have to check to see if it reduced at the end anyways. If nothing cancels, nothing's going to reduce. Example C. 2 4/5. Aiden Pasquale. What's 2 4/5 as an improper fraction? Okay, 14/5 divided by 7/1. Again, I'm not writing the negatives because I know 2 negatives gives me a positive. All right, yay, positive. Keep, change, flip. Maddie Cheeseman, what's this problem going to be after I keep, change, flip it? That's right. And Maddie, do you see anything that cancels here? 7 with what? Oh, that's right. Oh, that's right. 14 and 7 can cancel. 7 goes into each of those, goes into 7 once, and it goes into 14 twice. So I end up with a positive answer, like we said. And what's 2 times 1? And 5 times 1. It's the same thing you did last year. Why are we doing it again this year? Because last year you didn't have negative fractions. Well, big whoop. Just check it. It's either going to make a negative or positive, right? You have one of them, you have 2 of them. Same thing as last year. So maybe, again, if you didn't do well last year, this is your year to do better on this topic. Keep, change, and whoop, too fast. I got to flip that, but before I flip it, I got to turn it into an improper fraction. Ashlyn, what's 3 1/5 as an improper fraction? 16/5. That's right. And then so when I flip it, Ashton, what's that going to give me? 5. Ashlyn, why can't I? Okay, I caught myself that time. Yeah, when we flip it, it's going to be 5/16. Interesting. What cancels? Everything. The 5s will cancel. 5 goes in itself once. 16s will cancel. 16 goes in itself once. And you're going to end up with 1 times 1 on the top and 1 times 1 on the bottom. And unfortunately, even though everything canceled, we still have to reduce this. What is 1/1 the same as? Just 1. And I should have done this at the beginning, but I'm going to do it now. How many negatives do we have? 1. So they cannot pair up with a, no, can't pair up. So it's going to be -1. All right, let's get into some more complicated problems. Can the exponent see the negative? It's there. So this is the same as -1 2/3. Actually, I'm just going to write it as -5/3. I'm okay doing that. You guys just convert it right now. Times -5/3 times -5/3. What's 3 negatives mean? It's back to being negative, isn't it? 2 of them will pair up, 1 won't. There's still 1 lonely negative, so the answer is going to be negative. What cancels? All the 5s cancel, right? Why don't the 5s cancel, Georgia? That's right, they're all on top. When you cancel, you can only cancel a top number with a bottom number. So the only way this is going to cancel is if 5 and 3 would cancel. And I know 3 goes into 3, but does 3 go into 5? Yeah, nothing cancels here. So we're just going to multiply straight through it. 5 times 5 is 25. What's 25 times 5? 125. 3 times 3 is 9. What's 9 times 3? 27. Don't even bother checking to see if that reduces. You just told me nothing canceled. If nothing cancels, nothing's going to reduce. Example B. Let's turn -7 into -7 over 1. That's right. Yeah. What cancels? Keep in mind, you can cancel any top number with any bottom number. Maddie Cheeseman. Yes, the 7s cancel. They don't have to be next to each other. This 7 on top cancels with this 7 on bottom. 7 goes into itself once. 7 goes into itself once. Does 4 and 5 cancel? No. Okay. So what's 1 times 4 times 1? And what's 1 times 5 times 1? Yep. And what's 2 negatives make? So essentially what we have going on here is that 1/7 of 7 is just 1. So we're just multiplying 4/5 by 1, and that's why it's going to stay 4/5. That's why it's going to stay that way. Positive 4/5. Last question. What does 7 and 7/8 change into? 63 over 8. Nice job. That's a hard one. 8 times 7 is 56. 56 plus 7 is 63. So that's 63 over 8 times 2 over 3 times 3 over 2. And that's a lot of multiplication I'd have to do if I didn't cancel. But I'm going to cancel. Maddie says, what do you see that cancels?
3 and 2 and 2.
Well, that's like the whole problem. So does 63 and 8 cancel? No, there's no number that goes into 8 that goes into 63. I would agree with that. Okay, so if nothing cancels, nothing's going to reduce. How many negatives do I have? 1. So the answer is negative. And then do I have to write this as a mixed number? I don't have to. And you know what? If I did, it's literally staring me in the face. Right there. Right? That's what it was. Yeah, I don't have to write this as a mixed number though, unless the instructions tell me I have to. I think there was one like that on the last one where it said you had to write that. I'm not a big fan of that. You can leave them as mixed number or leave them as improper fractions. So that's it. That's your homework. Big ideas homework. It's going to say 2.4 again. It's not a mistake. 2.4 is on your big ideas twice because one's got decimals on it and this one's going to have fractions on it. Yep, and mixed numbers. All right, that's the lesson.